Hi everyone, and welcome to the AWS Nordics office hours with me, Gunnar Grosch. I'm a developer advocate here at AWS, and this is our weekly show coming to you live from the Nordics, where I bring on guests to talk about a specific topic and let you, our viewers, ask any questions you might have on that topic. And this week, I'm joined by Tom McCarthy for a look at how to use Arm and Graviton2 for your container workloads. So welcome to the show, Tom.
Thank you very much. Thanks for having me.
And you, Tom, you are a startup solutions architect based in Stockholm. Tell the viewers a bit about what you do as a startup solutions architect.
Sure thing. Pretty much all of my time really is spent either sitting down with customers and helping them design architectures on AWS, or preparing to do the same. Most of the time when I'm not sitting down with a customer and helping them build something, I'm working on a demo to try and show in a concrete way how something can be done, or working on design documents and things like that. In a small nutshell, if I'm doing my job well, the customers who speak to me have an architecture that's more reliable, more scalable, more performant, secure, etc. than if they had not. So yeah, that's in a nutshell. If I'm doing my job well.
Yeah, sounds good. All right. So as I mentioned, we want you, the viewers, to be active in this session. So if you have any questions, if you have any comments throughout, just post them in the chat. And Tom and perhaps myself will do our best to try to answer those questions. And I mentioned early on the topic of the day, talk about ARM and Graviton2 for container workloads. So I think we need to break that down a bit to get to the actual core of the topic. Should we start by talking about Graviton2, what that is, Tom?
Yeah, I think that's probably the best starting point. So Graviton2 is a processor, basically a processor that's custom built by us at AWS, using 64-bit ARM cores. I think everyone's probably starting to see ARM pop up pretty well everywhere in tech these days. But Graviton2 is the latest generation of our own ARM processors.
And where is ARM or Graviton2 rather used today in our services?
Oh, it's used all over the place. So the sort of the lowest level is EC2 instances, right? So you can go and spin up a Graviton2 EC2 instance instead of something based on an x86 Intel processor or an AMD processor. You can sort of choose Graviton2 instead of that. Then sort of past that, a lot of the managed services that we have are also making use of it, right? So if you're running your databases on RDS, switching to Graviton2 is pretty much as simple as going and changing a setting, right? Since we're running the database on there, there's not really much for a customer to do other than say, hey, AWS, can you run this on Graviton2 for me instead?
And the latest addition, perhaps, to the Graviton2 family was the ability to run your AWS Lambda functions using Graviton2 as well.
Right, exactly. Yeah, that's one of the very recent ones. Maybe even easier to switch over. Depends a little bit what you're doing in the Lambda function, but yeah, you can change a setting, and we'll just run that on the Graviton2 processors for our customers.
So that's a bit about what it actually is. Then the question is why? Why would you run something on Graviton2 instead of whatever the other options are?
Yep. It comes down to sort of two key areas really. One is the cost, or the price to performance ratio. So if you take if you look at EC2 and you take the sort of most comparable EC2 instance running on x86 architecture, let's say you pick the same number of virtual CPUs, the same memory, you're going to get around a 20% lower cost for running on Graviton with the same resources. That's only half the sort of price performance equation, right? So the other part is, we're seeing that lots of workloads are more performant on the Graviton2 instances. I've seen benchmarks from video encoding, from machine learning inference, from running Nginx load balancers or reverse proxies, from running things like memcached, a really wide range of examples. But generally speaking, the performance is getting better. Last but not least, there's also a big benefit in terms of the energy efficiency, right? I mean, if you're running ARM processors, the power usage is significantly lower than what you would see from running the same workload on an x86 processor, which obviously means the carbon footprint is going to be lower from running on Graviton2 as well.
That's an important question for I know for a lot of our customers and users today. So when we talk about that price performance thing around using Graviton2, as you mentioned, if we look at a simple example using EC2 instances, you could basically have an instance that has the same number of vCPUs, the same amount of memory, switch to that, a Graviton2 based, and it would lower your cost. But at the same time, it would probably also increase the performance of whatever workload you're running on it.
Yeah, exactly. I mean, and one of the patterns that we've seen quite a bit are sort of customers who, the first thing they do is dip the toes in the water, right? You want to try it with a single workload, make sure it works. So, they try one small workload, they move it over to ARM. That cost benefit is immediately realized. Okay, cool. It's 20%. It's costing 20% less. And then the next step is, hey, actually, we're getting a lot more performance out of this. We can scale down the overall number of instances that we're actually needing to run to serve the same workload. And that's, I think, when the real benefit starts to kick in, right? I mean, not only is it 20% less cost, it often requires a lot less resources overall to perform the same unit of work that customers are getting out of x86.
So basically 8 minutes into the show, it's a done deal. Switch to Graviton2, we're done. We can end the show. Or should we perhaps see this in action as well, Tom?
Let's do that.
So the topic of today was container workloads, which is one of the ways of running your workloads, of course. And tell us a bit about what we're going to look at.
Sure. So just quickly first, I mean, I picked containers just because I think it is such a prevalent way to build and deploy applications now, right? I think a lot of the things I'll go through today, there's definitely going to be pieces that are relevant for, someone just running an application on plain old EC2, right? And likewise, there's going to be some things that might be relevant for people who want to do some different things with start using the CDK, right? But maybe Graviton doesn't work. We're going to go through a few different topics. First and foremost, I'll mention I'm using the CDK for just about everything today. CDK is, just quickly, stands for the Cloud Development Kit. It's basically some infrastructure as code tooling that allows you to, instead of using something like CloudFormation or Terraform, you can actually use the programming languages that you're familiar with to build that same, build a code base that will deploy things to AWS for you. I'm using CDK particularly because for me, it works extremely well with containers. It's so easy to go and set up an EKS cluster to run Kubernetes on AWS with CDK. So I just mentioned that because CDK is going to be sort of part of a lot of my examples today.
And you mentioned familiar programming languages. What is your language of choice then, Tom?
Yes, I am. I'm a Python fanatic. It's almost a religion to me at this point. But yeah, everything's going to be Python. Actually, I do have a Node.js sample app, but it's teeny tiny. Most of the sort of interesting code is Python for today.
Right. So tell us, well, quickly, what we'll try to cover then, or what you'll try to cover in the demo.
Yes. So first, I'm going to try and sort of set a bit of a baseline. I'm going to show you, the thing I cooked earlier. I'm going to show you how I got my EKS cluster up and running with CDK, just so everyone sort of understands what's there already in my account. Once we've done that, I'm going to show you how I build a code pipeline to run, basically to take my application code, build container images that will work with ARM and with x86, and then take those images and deploy them to my cluster that has some Graviton2 instances, some x86 instances, and how we can sort of make that work. And that bit will be applicable. I mentioned Kubernetes. I will be doing this with Kubernetes, but the actual build pipeline is going to be relevant for ECS as well. Basically, wherever you're running your containers, that bit's just going to help you build this sort of multi-architecture container. Once I've done that, I'll sort of round that out, just showing how I can deploy it to EKS, and a quick demo of how that looks when it's deployed. And then we'll see, depending on how long that takes, how many questions we get. I can probably demo the same for ECS, or we can dive a little bit deeper into some of the deep dark areas of scheduling containers on specific instances and that kind of thing. But yeah, that's an overview of the topics for today.
All right, so a lot to cover then, and let's get to it. But first, this is the AWS Nordics office hours with me, Gunnar Grosch. I'm joined by Tom McCarthy today, and we're looking at running container workloads using Graviton2. So if you have any questions, comments, just pop them in the chat, and we'll try to answer those. Hooray, says Nocturnal Shake. So, yeah, hooray.
Awesome.
I'll bring up your screen share, Tom, and let's get to it.
Excellent. So first things first, this that you see on the screen is PyCharm. I've been developing in Python for 10, 15 years maybe now. I've lost count. PyCharm's sort of always been my go-to, my favorite IDE for writing Python. A lot of my colleagues I know are using VS Code. But I think the interface should be quite similar anyway, right? I think it looks very similar. I've got my project here on the left, and we're going to be looking at the code that I have here, and then I have some terminal windows down at the bottom. All right, so let's start walking through this. What I have on the screen here is a CDK stack, which is one of the high-level CDK constructs that I can use to define the stacks of infrastructure that I want to deploy. So what I'm doing, I'm pulling in a bunch of modules from CDK. I'm going to need EKS, which is the Kubernetes service. I'm going to need EC2 because I'm going to define the instances. And I need IAM to do some permissions. I've also got an import from something I called a construct, which I can dive into a little bit later. It's not super important for the time being. All right, so all of this is boilerplate, and a lot of it will sort of be generated for you when you get started with CDK. If you go and type CDK init, you'll get the sort of skeleton for a project where you can start defining your own stuff. So where I start defining my own stuff is pretty much here. So first thing I'm going to do, I need to create a role for my EKS instances. That's so that my the pods that are running on my cluster are able to do some of the things that they need to be able to do, like report logs, create log groups, control the Kubernetes CNI for the networking, and so on and so forth. I'm not going to go through all of this. Suffice it to say, I'm creating a role here, and then I am adding some other policies to that role as well that I needed for the cluster autoscaler that's going to get deployed into my cluster. A lot of noise here to do not so much. I'm basically just adding a role with all the permissions I need. So let's get past that.
And what we're always saying when we're talking about something in CDK is compare this to writing this yourself in YAML or JSON with CloudFormation. It is a lot easier to use the CDK.
Absolutely, and I think the best possible example that I can find of that are the next 3 lines that I have here. This is building me an EKS cluster. If you do this in CloudFormation, you'll find you have to do quite a lot of things. You'll have to define a network and so on. But CDK is one of the great things with it is it has sort of more opinionated defaults, right? So I can do this. I can say, hey, give me an EKS cluster. And it's just going to sort of work out a lot of the rest for me. If I need more flexibility, if I need to be more specific about my networking and things like that, I can. But for this example, this gets me as far as I kind of need to go here. This is where it starts getting interesting when we talk about Graviton. You might notice I have this default capacity as 0 on my cluster. If I just wanted one node group, I could set that to however many instances I want and set the type of instances and things like that. In this case, I want to be a little bit more clever. I want to have a few different node groups in my EKS cluster, and those node groups are going to be the workers, right, that are actually running my pods and actually getting the work done. So I have 3 node groups that I've created here, each with the add node group capacity. One is going to be some standard run-of-the-mill x86 instances. You can see I choose the M5 large instance type for those. And because this is actually creating an auto-scaling group under the hood, I can set a min size and a max size as well. And then I give it the role that I created just above. Then I actually have 2 different node groups that are running m6g.large. And that is when you see that G at the end of the family name, that's Graviton2. So M6G, C6G, R6G for the general purpose, compute optimized, memory optimized. And then there are T4G as well for the burstable instances. Those are the Graviton2 ones. In this case, I've just used m6g.large, which is the sort of closest equivalent to m5.large. And in one of those node groups, I've decided, a bit more price performance is awesome, but I want even more. So I'm going to use Spot for one of my node groups as well, which is going to use. Yes.
Yeah. Quick rundown of what Spot means. Spot instances.
Absolutely. So the default instance type when you go and create an instance on AWS is on demand. It's exactly what you expect and what it sounds like. You spin up an instance, you pay a set price for that instance, which and then when you turn it off, you stop paying. Spot is a bit different. It's basically using the extra capacity that AWS has, sitting around in the data center that nobody else is using right now. And the price for Spot varies depending on demand for that type of instance. It's cheaper than on demand. The caveat is it can happen that there's no Spot capacity available. Or if you're running a Spot instance, AWS might reclaim that capacity with a 2-minute warning. So that's why I have this on-demand node group as well below it, right?
So it means that Spot instances, you perhaps use it for certain types of workloads. It could be test workloads, or it can be running certain types of tasks that are, with the possibility to actually interrupt that running task.
Exactly. If you're not too worried about, the workload sort of stopping halfway through, and you can sort of reinstantiate it and resume or start over, and that's fine. It's a good workload for Spot. Kubernetes and container orchestration changes that equation a little bit, right? Because of how I've set this up, and because Kubernetes gives me a lot of flexibility over sort of how and where my workload actually gets scheduled, which instance it runs on, I can be a bit more resilient I can tell Kubernetes basically, hey, if my spot instances go away, or if we can't scale up into spot, scale up into on demand instead. So yes, then maybe we'll get an interruption, but usually, if so, it'll heal itself quite quickly. But yeah, that's why I'm using spot. Absolutely not required. I wanted to put it in because I love how simple these things are in CDK. The only difference between this node group and this one is this one line here, which is basically telling it, for this node group, use spot instances if they're available. And to be honest, that's pretty much it for actually setting up my Kubernetes cluster. I do have a little bit more code where I'm adding my own role as a system master, as Kubernetes calls it, so I can go in the console and click around and show you some things with a role that I have already. It's not super important for the actual sake of the demo today. I will mention, and this is another thing I'm happy to dive into a bit later if people are interested. But another thing that CDK lets you do, everything I've shown you here is sort of setting up AWS resources, right? It's an EKS cluster. It's node groups to run on that cluster that are EC2. CDK also lets you deploy Kubernetes manifests and Helm charts to actually get those things running within Kubernetes, right? So it's not AWS resources we're talking about anymore. It's Kubernetes native resources. And that's what this bit is. I mentioned all the way up at the top, I was pulling in a construct of my own. I'm then calling that here. And what that's doing is basically making my cluster, I won't say production ready, but a lot closer to production ready. It's putting things there. It's deploying the cluster autoscaler so my nodes can scale up and down. What else? Metrics server, so the cluster autoscaler works, and a bunch of other things. I'm deploying Prometheus, Grafana for some monitoring. Yeah, loads of cool stuff in there. But like I say, we can come back to that one if someone has a particular interest in that part. For now, I want to show some build pipelines.
Yes.
So first, just quickly, what that gives me is, this is my EKS cluster. Right now, there are only 2 nodes running in there. As you can see, one M5 large, one M6G.large. And if you look in my default namespace, I actually do have one deployment running already, but we're going to make another one so we can see sort of start to finish how that looks. Oops. Where are we? Apologies, got lost on my screen.
Too many windows.
Too many windows, far too many windows. Right, I should show, actually, sorry, one more thing before I dive into that. So this is me defining a CDK stack. What I've not shown is how that actually sort of gets connected to what I'm going to deploy. So in the root of my project here, I have app. Again, this is something you'll get a lot of help from the CLI from. It will basically generate a file like this for you. But basically, I just create a CDK app, and then I add my stacks to it. So here I'm adding the CDK stack, the EKS CDK stack that I walked through. And I can add a bunch of other ones as well if I want. So a single sort of CDK app can have multiple stacks. So if I drop to my terminal below and hit CDK list on this project, it's just going to quickly show me, basically, it's going to reflect this. It's going to show me the stacks that I have. So there's the AWS EKS CDK stack and so on. Right now, let's move over to our multi-arch pipeline stack. So what this is going to do is create a code pipeline project that's actually going to be responsible for building my multi-architecture containers. I think in this case, I'm actually going to show you how it looks from the sort of pipeline, and then we can dive back into the CDK just to break things up a bit so we're not staring at my staring at my IDE for too long.
Yeah.
All right. So what I have here is a pipeline stack for Python. I've called it multi-arch pipeline stack Python. I'm going to just grab the name of it from there. I go CDK deploy multi-arch pipeline stack Python. So under the hood, what the CDK is actually going to do here is generate. It's going to generate CloudFormation templates out of my CDK, and I can, if I want, I can have a look at everything it's going to build. But let's just go ahead and do it, and then we can have a look in the console after that's done. So while that's building, I can show you, here's one I made earlier. So that's going to create, first and foremost, let's see. It's going to create a code commit repository. You can think of that like a GitHub repo, right? It's just a code repository where I'm going to host my application. We'll see soon here, one's going to pop up called multi-arch app Python. But for now, we just have the Node.js one. And if we click in there, we can just see this is just my application code. I can show you the application code as well, but it's very, very simple. It's basically just a server that's going to echo which architecture it's being run on, which processor architecture. That repository, there we go. Python repositories popped up now. So that's the CDK working in the background. It's going to connect that repository. The repository is going to be empty when it creates it. It's just saying, you know, put your code here and we'll build it. Code pipeline is going to be sort of doing the legwork from there. It's going to create a code pipeline for me, and that code pipeline is going to have 3 steps. It's a very simple one. It's going to have a source step, and in this source step, it's going to pull in my code from code commit. It's going to trigger automatically when I push a commit to code commit. And code pipeline does support GitHub as well. If you have a preference for GitHub, for example, we could use that instead. Then it's going to kick off a Docker build, and you can see this is split into two parallel steps here. Excuse me. It's truncated a little bit here, but we're going to build x86 and we're going to build ARM. Now, so those two...
Yeah, so it's fetching the same source and using those assets to build 2 separate...
Exactly. The only difference between the two is one of them is going to run on... code build is going to build it using an x86 machine, or it's going to use an ARM machine to build it. The code's the same. I think we are going to tag the images differently as well, because we want to say, hey, this is the ARM image and this is the x86 image. We're actually going to create 2 different Docker images here, and we're going to publish 2 different ones. I mean, that's not particularly magical or useful, because if we've got 2 different Docker images, when we actually go to deploy it, we're going to have to say, hey, Kubernetes, I want you to run this manifest with an ARM image or with an x86 image, which isn't particularly helpful. We don't want to have to worry about that. We want Kubernetes or our container orchestration of choice just to be able to say, hey, I want this application image. Give me the right one, ARM or x86, for where I want to run it. So that's what this last step is going to do. This last step is basically going to create what's called a Docker manifest list. And what that is, basically you can create a multi-image Docker container. And then when I go to pull that image, each layer is going to be annotated with the architecture that it's using. And then the runtime that actually runs that container is going to be smart enough to know, okay, the manifest has references to 2 different images, and I know I need the ARM one for this particular instance, so I'll grab the ARM one. It basically abstracts away that choice of whether to pull the ARM or x86 container. So any container we build through this pipeline, we're just going to be able to run. We can even go and type Docker run app image latest. I'm on a Mac that's on x86. I'm not lucky enough to have one of the cool new ARM ones. But if you were running an ARM Mac, we could run the exact same command and we'd pull a different image to support the right architecture.
That's cool.
Let's see how our progress is. Okay, this should be done really soon for the Python one. Actually, and we see already it's created the Python pipeline and failed. And that has failed because it's trying to build what is right now a completely empty code commit repository. So I have here on my screen a Python application. And it's also very simple, Flask app that's just going to do the same thing. It's going to echo which platform we're running on. And let's change Hello World to Hello Twitch just to prove I'm actually running this thing. One thing that's important in here is this build spec and manifest build spec. So this is how code build knows what to do for my project. So when it runs let me make this a bit bigger. When code build runs that parallel step that I showed before, these are the steps that it's going to take. There's nothing special in here. If you've sort of created a Docker application before, we're going to get the commit hash, and then we're just going to we're logging into ECR, which is the Elastic Container Repository, which is where we're actually storing our container images. I'll show that in the console as well. But yeah, this is what's happening when the application gets built. It gets built and then tagged with the architecture that we're using. So let's grab the URL from our repository that we've just created, that CDK has created for us. And I'm going to add it as the origin. Remove origin. Remote remove. There we go. Tongue twister. And then we can add the new origin and we can push our code. I already have a get. This is all a get repository already, but now we're going to push. And what we should see now, if I refresh my repository and code commit, is the code that I've just pushed. Excellent. That should also mean that my pipeline is running, which it is, in progress. And we can see now that the build has started. So while this is building, while we wait for this, I can show you what this step does. Yep. The manifest step. So the manifest step, the magic is happening here. It's this docker manifest command. So we're going to create a manifest. And there's a lot of variables here that make it a little bit tricky to see exactly what's going on. But this is basically just referring to the image, the image URI as it's already stored in ECR. And then we're going to annotate that manifest. And we're going to say, okay, I want to annotate ARM64. And I'm going to point that to my ARM image. And then we're going to annotate AMD64, which is x86 64. There's a lot of different names for ultimately the same thing, but this is our x86 annotation, and we're pointing it to the x86 image. And then there's a command here to inspect. That's just an echo, basically. And then we're going to push the manifest similar to how we would push a normal image. And then just for convenience, I'm storing it as a parameter in AWS parameter store in case I want to grab that container URL later on without going through the console.
And this is simple code build syntax that it's using.
Yeah, exactly. This YAML file is a well-known syntax for code build. It's dead simple. You see I have these phases: pre-build, build, and post-build, and in each one I just put shell commands basically that are going to be executed. You find sort of similar syntax if you use something like GitHub Actions. I think most CI/CD tooling has something similar to this, where you can just sort of define the build steps that you want to happen. But yeah, there's nothing sort of special about code build in this. It's just the easiest way, you know, with AWS to run a set of build commands. Let's see how we're doing. Okay, so we can see my x86 build is done. The ARM build is still happening. So while that's in progress, I can actually show you ECR as well. So, oops. These are my repositories. You see I have one for my Node.js app, and I have one for my Python app, and then another one that's nothing to do with this. So let's look at Python. So you can see, as I mentioned, the x86 build is done. What we have now is our x86 image is built, and it's here in the repository. So I could run that if I wanted. But you see that the tags that I have here both mention x86. So at this point in the build, you know, I would have to know which one I want, which, as we said, isn't ideal. Let's see, still going with the ARM build.
In the meantime, if you have any questions, just pop them in the chat. I know Tom is racing through a lot of different things here, so if you have a hard time keeping up, just ask, and we'll dive deeper onto that as well.
Yeah, absolutely. Please do ask questions if you want me to focus on one specific topic a little bit, because as Gunnar said, I know there's quite a lot to take in here. I will mention as well, Gunnar, I know you're going to share a link later to a workshop. But we have a Graviton2 workshop where you can basically get the CDK code that's very similar to the CDK code that I'm using. And there's sort of guided steps for you to deploy that to your own AWS account and basically build this that I'm doing here, right? A multi-architecture container build pipeline. So if you get a bit lost there, don't worry, there is an opportunity for you to sort of do it yourself and fiddle around with it.
Yeah, I just pasted that link in the chat already. So
excellent. And we can see now we're onto the manifest step. So if I look in my repository again, cool. Now I have x86 and I have my ARM64 container. All we're waiting for now is the manifest that ties them both together. Because, you know, like I said, this isn't that much use on its own.
And where does that manifest end up? Is that also in this repository?
Yep, it's going to look, it's from looking in this repository, it's going to look very much like any other container image. It's not going to look special. The difference being you'd be able to run a command like docker manifest inspect if you want to see what's in there. But just from this pane of glass, in fact, there you go. You can see it right away. So yeah, we have our manifest here, and it's tagged with the commit hash. I actually left the latest tag off just because I wanted to make sure we demonstrated that we're deploying a specific thing, and latest makes it a bit hard to reason about that. So what I'm going to do is I'm going to grab my image URL, because now we need to deploy this, right? And if I can find the right project. So this is my CDK project that I was walking through before. I also have in here a bunch of Helm charts that have no relation whatsoever to CDK. It's another way to deploy things to Kubernetes. I think hopefully quite familiar to those who are using Kubernetes already. I just have some charts stored in here for convenience sake. So just don't want anyone to get confused about where they are in the project. That they're nothing to do with this project. I just wanted to keep them here for the sake of the demo. So I have this one here called multi-arch app. It's extremely simple. You can see I've used it here to deploy my Node.js app. So let's change the variables. Oops, change the variables here. I'm going to use the URL I just copied from the console for my Python app. And I'm going to put the tag down here. And then let's see, we're going to do Helm install, and then the name. So let's call it multi-arch app Python. And then I just need to point to the chart. So that is multi-arch app, as you can see here. So Helm's going to do its thing and deploy this. Excellent. And let's have a look. This is my new favorite tool, by the way. I only found out about this one quite recently. It's called Lens. It's like a Kubernetes IDE. It's fantastic if you're like me and just can't, for the life of you, remember all of the thousands of CLI commands you need to use with Kubernetes to check on things. So what I can do here is, I can look at the pods running in my cluster, and I see I have these two new ones for the multi-architecture Python deployment. I can see that they're both running since 28 seconds ago, so my deployment went fine. Now we can, so this is my Node.js one. And there we can see, if I refresh this a few times, so we have, again, some different names for architecture, but x86-64 is our M5 large, and then Arch64 is our Graviton2 instance. And you can see when I'm refreshing this, it's flapping sort of back and forth between them. So my container is running on both architectures. It's running on each of my nodes. And I have just, as you saw with my Helm chart here, I haven't told it anything about the architecture. I've just said, hey, run this image. And because this image is actually a manifest list, Kubernetes or container scheduler of choice is able to sort of pull in the correct one and run it. Now, in a sort of production world, this wouldn't be an automatic, this wouldn't be a manual step, right? I wouldn't have a pipeline that builds my container and then have to go and grab the values and put it in and type something on the console to deploy it. That's another sort of piece of this puzzle that would be automated as well. And chances are, if you're running a container-based workload, you have this sort of automated already to some degree. I just wanted to keep it this way for the sake of the demo, so it's very clear sort of what's happening where in the process.
But it would be quite easy to add additional stages to the pipeline, or steps to the pipeline.
Absolutely. So which sort of brings me to my next part. If we don't have any questions at this point, I can actually. So I promised that I was going to show what the CDK code looked like to build my multi-architecture pipeline. So I could drop over to there, and when we look at that, I think you'll see sort of how simple it might be to add extra steps. So let's go back into our stacks. And here we have our code pipeline multi-arch pipeline stack. I'm no good at naming things. Right, so this one's a little bit bigger. And it's also very, 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 very similar to what you'll get if you go and run through the workshop that Gunnar linked. So if you want to play around with this, that's a great starting point. So the first thing we're doing is creating the sort of root things that we're going to need. We're going to need an ECR repository to store our container images. And you'll see a lot of the time here we're using variables to name things. That's always a good idea with CDK and maybe with sort of infrastructure as code in general. Because if I don't do that, if I try and deploy this stack twice, I might end up with a naming conflict if I'm trying to name two things the same. Doing it this way means I can deploy this whole stack twice. And as you see, I did it once here for my Node.js app, and I did it once for my Python app. And it's the exact same stack with a different variable passed to it for the app name. I'm going to create my code commit repository, which I, of course, might not need if I'm using something like GitHub. I might sort of just point there instead. And then I'm creating the pipeline, which is sort of the the top level orchestrator, right? It runs all of the other things. It pulls in the source. It says, hey, run these build steps, and then run another build step after those two have completed. Then we have our outputs that we need to define. And these are basically the outputs from a previous code pipeline step. So we say the source output is going to be the output from that source stage. And then we're taking the outputs from previous steps and we're going to pass those through to the next step. Again, this looks a little confusing when you look at it like this. But I think if you've used code pipeline, it probably makes sense. It has this concept of each build stage produces an output, and then you can link that output to various other places in the pipeline. So obviously my build step is going to want the output from my source step because that's how it actually gets the code. Then we're defining the build spec files, those YAML files that I showed you before. We're basically just defining where those live in our application repositories. Then we create our pipeline project. And actually in here, you can see we have a bunch of stuff regarding or pertaining to how to actually do the build, right? So this is our Docker build 86 and Docker build ARM 64 steps, which I can, just for reference, just drop back to. That's setting up these two steps here. I may have mentioned that I love CDK, and that's very true. With Python, sometimes the typing is a little bit awkward. So you can see my IDE is complaining about the types here, despite them being correct. And also, this is a bit, at times, it's a bit verbose. So I have all this code basically to say a string of x86. I just mentioned that because it might look quite complex and confusing from here. I think most of that is just due to the type system, which if you're using an IDE, it will basically autofill most of that for you anyway. But yeah, this is where my build steps are being defined. And then finally, we're defining our manifest step. Similar thing, we're just telling it which build image to use. And then we're pointing to the build spec that we defined above. I would just actually, I missed pointing out one thing. This is the important part for the ARM 64 build. We're saying when you build this, use the build image that is going to use ARM. Whereas on this one, we're just saying use sort of plain Amazon Linux, right, to do the build. Other than that, there are no differences. Finally, we're going to add some permissions, which is what's happening here. Again, this in CloudFormation would be some YAML or JSON that would be quite long. Here we can just do it with a single function to grant the pull and push permissions for our repository. Finally, a few more permissions things that we're putting there. So for example, here I'm saying I want to be able to put an SSM parameter. And then finally, we're adding our stages here that sort of wrap up the actions that we've defined above. So here you see, we're wrapping up those build actions and saying we want those to be in a stage called Docker build. So here you see we have our stage called Docker build, and then within it are contained these two actions. And that's pretty much it for the actual stack being deployed. Like I say, if you want to try this out, go have a look at the workshop. It will walk you through CD code very similar to what I have here that I've walked through. I've made some tweaks to make it more reusable so that I can do this. I could have, several of them if I want. If I wanted to run 20 different applications, I could sort of bootstrap all of them the same way and just call them something different.
Yeah, and as you showed now in that CDK stack, it would be easy to add additional stages to, for instance, start using those newly built images as well then.
Exactly. And then, I mentioned that I'd sort of kept it simple for the sake of the demo, but even more than that, especially when we're talking about Kubernetes. There are so many different ways that I've seen customers actually create their build pipelines, right? Some of them have, I've seen lots that sort of work like this, but then the manifest, instead of just publishing the manifest, it might actually go ahead and publish a Helm chart to a Helm repository that would then could be deployed by a separate pipeline. Or it could be a simpler one. It could just basically say, all right, we've got our manifest built, just deploy it in the next step. You might have a deploy stage here. But yeah, there are so many different ways of doing it. I didn't want to be too opinionated on that bit because I was hoping it would be sort of relevant for a wider group as well.
Yeah, no, I think that's great. So looking at that Graviton2 part of this, going back there again.
Yep.
So in this case, you're using both x86 and Graviton. Is that something you see as common, or is that only applicable in these kind of test cases, perhaps?
So it's a really good question. I think it's applicable in lots of workloads because it could be that, it's quite often, if you get a Kubernetes cluster, it's not just one team deploying one application to said cluster. Often it's 20 different teams who might not speak to each other that much, who are all working on their own thing. Some of their applications might support Arm, some might not. So I think having having a cluster with the ability to run either or mixed workloads, I think is a good thing. The bit that's maybe a little contrived from my demo is in my Helm chart. If I actually show you what the full chart for what I deployed, I'm doing some things here, and this is for those in the those viewers who've been around Kubernetes a little bit. I have it basically set up so this topology spread constraint is going to basically mean when I deploy my application, it's going to be spread as evenly as possible over the different architectures that I have. And those are x86 or Arm. That doesn't make a ton of sense for a production application, right? I can't think of too many scenarios where it would be important that your application gets sort of equally spread across Arm instances and otherwise. But obviously my demo wouldn't really work that well if I refreshed and it was just running on the same architecture a bunch of times. But yeah, with Kubernetes, you can be extremely flexible with the scheduler and where your pods actually get spun up. It's very easy to say, I don't want this pod to be scheduled on an ARM64 instance, or vice versa. I only want this to run on Arm. And yeah, if you want to experiment, it's quite easy to do so with like a small portion of the workload as well, being deployed onto Arm. But yeah, so I think that was a long answer. In conclusion, I think having multiple architectures running as different node groups in a single cluster makes sense. It makes sense for Kubernetes. It makes sense for ECS. But it depends how you sort of set up the scheduling around that.
And the switching to Graviton2 part, or perhaps enabling starting to use it. What do you see there? How do customers start also using Graviton2, for instance?
Sure. So I alluded to this a little bit way back at the start, right? But often customers are picking. They're moving their RDS workloads, their Elasticsearch workloads, because it's very little work there. Because as I mentioned before, it's AWS who's running the software there on top of the Arm instances. That tends to be the first step we see customers take who are using those services when they realize, oh hey, we can do the same thing on Graviton2 for 80% of the cost, or maybe even less depending on the service. From that point, customers are basically picking a small workload to start with. Nobody's sort of going in, all right, move everything over to Graviton immediately and we'll see what happens. I mean, nobody's taking that kind of big bang approach. People are finding small workloads and testing those out in isolation, running some performance benchmarks to see sort of, how is this actually performing? And
but
then,
that's also part of it, to be able to do that. You don't have to do these kind of big bang switches to a new architecture. You can just move workload by workload, or in this case, use both at the same time.
Yeah, absolutely. And one other thing that I wanted to mention there as well. I mean, it does depend significantly on what your applications look like. So I showed a Python and a Node.js application. Those are interpreted languages. So interpreted and languages that compile to bytecode, like Java, .NET Core, they will run, generally speaking, without needing any changes on Graviton2. There is a caveat there, obviously, if you have dependencies that require, like some Python packages have C dependencies, right? For them, you would need to build on a different architecture. You'd need to build it on Arm for it to work on Arm. But for the most part, with those interpreted and compiled to bytecode languages, it's not much work to get it to run on Arm, if it's any work at all. The applications I showed obviously are very much hello world, right? So they will work perfectly on either. Then if you're using something like Go, you have a multi-architecture tool chain built in. So it really depends a lot on the application, how much work it is to get it running on Arm.
But that also goes back to your testing strategies and making sure that you're testing for both architectures as well then.
Absolutely. It's something that the first step has to be experiment, right? There's no single workload of a significant size that I would look at and say with 100% certainty this will work and work better on Arm. But there are also very few that I'd look at and say, it's not worth experimenting, just because some of the benefits that we've seen have been, enormous, right?
So final question for you, Tom, before we just wrap up. In your Kubernetes cluster right now, you had 2 nodes running. Can we just simply show the price difference, or if you have, I think you have that noted down?
Yeah, so just let me check. I think it is back to my favorite tool in the world right now. Where is it? So yeah, this is M5 large, and this is M6G large, and the price. So for at on demand, it's 96 cents per hour for our on demand, and it's 77 cents per hour for our Graviton2 instance. It's going to be a bigger difference for me than that because I'm using Spot in some places. But those are both the on-demand prices. It's basically a flat 20% cheaper with Graviton2.
Cool. All right, and then we have the performance part, which means that you perhaps would be able to switch to a smaller instance size as well.
Yeah, or fewer instances at least.
Yes. All right, Tom, final minute of the show. I want to thank you for joining us today, walking us through this. A lot of information in short time. So I've pasted a link once again for the workshop. So do have a look at that and dive deeper into the different topics. Thank you very much, Tom. Thanks for all the viewers. I hope you enjoy this, and I hope to see you again next week. Bye-bye.
Thanks, Gunnar. Bye, everyone.